society, as you guys know. Thank you for all coming. So today we'll be learning about loops. So what is a loop? So the foundation of iterative logic subtitle. So master loops to automate for automotive engineering and data workflows. So objective: to understand the fundamental and logical structures that allow computers to handle repetitive tasks with high precision and speed. The big picture: in digital processing, we don't process one sample at a time manually. We use loops to sweep through millions of data points in milliseconds. So basically, let's say that we have, I don't know, I was talking about lists. In programming, you might have a list or something like that. So you might have a list or an array. So a list or an array, you know, you might have some things in that list. It might be 1, 2, 3, 4. In the array, you might have 4, 5, 7, 8. So now you might have a list or an array here in your program. And now basically with your list or your array, is this thing recording? It's still recording. Anyway, so within your list or your array, basically, you might have some different things within your list or array. So now, what you want to do with these things is maybe you might want to process it, but now you don't want to just process it one by one. So now with a list or an array, what you can do is you can print it out. So you can do print, you can do a print function, and then you can do array, and then you can pick a number from 0 till the end. So now you can say maybe the first one. So now you say print array 0, print array, and then 0 within the brackets. And then on the console side of it, basically what you'll see on the console side of it is you'll see that it will print out the 0th part of the array, or same thing with the list. Print list, and then maybe 2 to show the second one, which is the computers count from 0 going upwards. So with computers, you always start with the 0th figure and not the first figure. So that's the difference between us and computers. So now you might want to have a list, but maybe you want it to print out everything within the list one by one for some sort of digital processing or something like that. That's where we come up with loops. So why use a loop? The power of automation in programming, efficiency versus labor. That's not a good explanation. So anyways, let's say we have people within the class. What's your name? Pardon? Americo. Okay, we have Americo, Martin, Simata. Americo, Martin, Simata, and Aaron. So now, let's say we take all of you guys and then we're to put you guys in an array. And now, let's say the program is me. And then there's somebody else telling me that they want me to call out each person. With normal print functions, basically how it would go is this person is like, call out Americo, call out, pardon? Martin, call out Sim. Iteration for fixed destination. Use a loop for when a number of iterations is known for a loop. MATLAB syntax breakdown. So now, let's say when you're, so now we have two main types of loops. Yeah, sorry that the notes look like that, guys. I was writing it off of a project that I was doing, having to do with MATLAB. So now we have two types of loops, a for loop and a while loop. Now for loop is a lot more specific, because now with a for loop, before you'll you'll have what you want, you'll have what the defining function within these brackets, and then you'll have the normal brackets where you'll define how everything goes. So now there's 3 parameters within a for loop. First is the initialization function. So what is the initialization function? The initialization function is the function which initializes how things go. So let's say we have int I equals to 0. That means that what we want to repeat is, comrade, I'm good, how are you? We're D. Of all days we're getting interruptions, it's D. Anyways, int I. So now this is our initialization, because now we want to print out I. If you're asking me what I is, usually within loops, people like to use I as the variable. So now, as you remember, there's variables. I is the initialized variable. We'll start it at 0. You can start it anywhere you want, honestly. You can even start it from 2 or whatever. So now, that's the initialization variable. So now, the parameters basically are what you want, when you want the loop to stop. So now you could say for int I less than 10 maybe, and then you have the operation that you want it to do. So now you can do, there's 2 main operations. There's I++ and then there's I minus minus. This means that you add 1 to I continuously. This means that you minus from I continuously. So now you can do that, and then you can say print I. If let's say we're to make a function, let's say that we're to make our for loop look something like for int I equals to 0 with the parameter of I less than 10 and the operation I plus plus. What we've done here is we've created something that starts counting from 0 going on till 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's basically any sort of repetition. You can use loops for anything. Let's say you just wanted to impress your mom and create a simple counting function. You can use loops to create a simple counting function. Let's say you wanted to process data or something. You can use a loop. Let's say you connected to something, to a voice-over module here on your thing, and then you wanted to call out names. You wanted to create a PA system with your Arduino. You could also do that, and then it will start calling out names at the intervals or once some sort of interview process is done. Let's say you're working for a company, and then they have an automated system that calls out names. Let's say you're working for F&B, and now F&B at the start of the day, they want to start calling out people at regular intervals. You can program it with your Arduino and then you can make it call out names at regular intervals within that loop. You can save people in an array, and then you can make it call out names at specific times. So that's one thing. So that's one use for loops, honestly. That's for loops. Does anyone have any questions about for loops or anything about loops in general?
Does it only apply for things that are maybe multiple or something?
Multiple.
Maybe a lot.
It can apply to anything, honestly. You can make anything repeat with a loop. And now with for loops, they usually have an end, because now it has the 3 parameters: initialization, the parameter and then the operation. Whether you want it to increase or you want it to decrease. It really depends on some things. So yeah. So when it comes to these things, you can basically use it for anything. It doesn't matter if it's multiples, small number of things, as long as you have something that you want to repeat, or let's say a list you want to repeat. You could say print. You could say print list, and then instead of putting 2, you can put in I. And then maybe the smallest one is 4. So then it just continuously prints out things. We'll do an exercise on this one later. But for now, I'm gonna go into the next one, and that is while loops. So, a while loop. What is a while loop? So basically, with a while loop, what you're doing with a while loop is basically, it goes on forever until you want it to stop. So now, as an example. So now, you can make your parameter. So now, let's say the figure that you're increasing is I. Let's say you want it to run forever, print. What you can do is, you can say print I, and then you can do I plus plus. Print I plus plus, and it will continue running forever with no stop. Basically that would be something like the void loop. The void loop kind of works like this, where it says while I, and then it just increases I with no direction. It just continuously increases I. Or what you could do is, you could give it a limit. So while I is less than 2, and then it will continue increasing I up until there's nothing else. But now you see, with while loops, there's no initialization factor.
How long is it?
In here till about 5 or 5:30. Wait, let me.
We didn't have a project on our face.
Pardon?
We didn't have a project on our face.
Which venue were you guys
The
at?
next one right there.
Oh,
Yeah, so when you guys are finished, we'll just postpone. We wanted to watch the short film, but we'll do that towards the end. You're not gonna be coming in.
I did.
Oh.
Cool. Anyways, now what's this one? So anyways, so while I is less than 2, print I plus plus. So basically that's how a while loop works. So now this is the operation. The operation is within the bounds of the loop. And what you want it to do, here's the function that you want to repeat, and then here is the condition. So now here there's just a condition and then the operation. But you see, one thing that you'll notice is that there's no initialization. With the while loop, it automatically knows that I, if it's here, I is probably going to be 0 or something. But you'll have to initialize it yourself. So int I equals to 0. Basically, with a while loop, you don't need these features within it, but you can still add it, but you'll have to add it outside. But you don't need it. Let's say you just you took this away. It will continue printing on forever. Let's say took this away. So just start from 0. if you took this away, nothing will be, it will just do nothing. You'll just have awkward code around. So the least you could do is this. I would also just recommend that you just initialize it from the beginning. And then that's how you get a while loop. So that's how loops work. There's also a bunch of interesting stuff that you can do with loops. From the last classes, you guys still have the photograph of the code from the first class, right? On the group. Let me check if you guys still have it. If not, then I can just show you guys what I want you to write down since we have it. But anyways, a really cool thing that you can do is, let's say you have A equals to A plus by 2. And then you are to create a while loop. A equals to 1. So it's initialized with this, and then straight after you initialize, and then straight after that, A equals to 1, and then like that. And then you say while A, then you say print A. Then you won't need to do the A++, because basically it will continuously continue printing A, because now A is getting, 2 is getting added to A. And not only, and now A is continuously increasing, because it starts off as 1 plus by 2 equals to 3. And then while this while function will continuously continue printing it as it increases by A again. So then 3, you can use that for a lot of operations, for a lot of iterative processes and stuff like that. Maybe you have an equation that you'd want in mathematical form, which you can use with MATLAB. If let's say you want to use a mathematical format for something, you can use MATLAB to kind of code with maths. But MATLAB is a class that I'll be teaching later on within the semester. So yeah, man. So yeah, that's basically some of the stuff that I'll be showing you guys with the board markers. Now it's time to actually get to the proper code. Alright then, as you guys can see, please open up your monitors and your everything. You know what, let me show you guys how to create a new project with MATLAB, with Tinkercad. So basically, here on the website, you'll have press here on the Tinkercad logo to go to the main page, and then after that go to the circuits part. Add circuits near, press create circuit, and then create a circuit. But anyways, before we start with that, does anyone have any question on while loops? Alright then, so as we continue to go on, press here add code. So for you guys that were there for some of the first lessons, here is how this code looks. But let me not do funny things. Let me do You guys still have Python, right? So anyways, within your Python code that we did last time, your Python projects, please, so within your Python codes from last time, we're going to do new print functions. So anyways, let's say that we're going to create a for loop with the parameter, with, let's just say basic parameters, int I plus plus, print I. So I'll just need you guys to write this. And now with Python code, there's another interesting thing that I forgot about. You write for, inside of the code, you write for I in range 10, which is something specific towards Python. Because now here in C++, code, for I int 0 print. So now here for Python, you guys will just need to write this. And now, let's say right now you guys want to print, let's say that we want to create an array. You guys can just give me a suggestion. What do you guys want what do you guys want to be listed out with? What do you guys want to be done with this for loop? Do you guys want me to create an array of people's names, call it class, and then we start listing out the people's names, or?
I think you can use numbers.
Pardon?
I think you can use numbers.
Numbers. All right. What number do you want it to start at?
1.
So yeah, this is how it's written in Python, the for loop. So it's for I in range, and then you say from 1 till 10 with a comma here. So now you can print that out, you can use numbers, you can say 5, from 5 till 10. And then it will only print out. But remember that when it comes to numbers here within computing, computers start from 0. So now when you say from 5 till 10, what it understands it is from the fifth number, which is from 5 till right before 10. So that's how the for loop works. So now let's comment this out. So now with the while loop, so now with the while loop, while true, user input equals to input. Nah. This is more difficult. So anyways, what I was teaching you originally is the C++ way of doing things. For Python, it's while true. So now this goes on forever. You can say while true, print hello world, and then we can stop that because we really do not want to break our computer. Why is it not stopping? So anyways, print hello world. Oh yeah, I hope you guys did not type in the while loop that was originally displayed. But yeah, never ever type in a while loop just like that with no parameters. It will continue printing out stuff forever and it will destroy your PC. A great example is like what happened here right now, which is why if you're wondering why I went out of that, yeah, technical difficulties. So here for the while loop, we start with I equals to 0. So while I is less than 10, print I plus equals to 1. So as you can see there, if you were to type that into your own code, it will print, you'll see here in your console, it will print from 0 till 9. So the bounds will always be 1 less than the number that's there, because computers count in strange ways when it comes to integers. They always start from 0. They count 0 as like the first number, and then like as they go up, they always go, or specifically for this one, since we're saying less than, you can say less than or equal to, if you also wanted to. And then it will include 10. So you can do many things such as that for while loops and other such functions. So yeah, that's just an example of something that you can do within loops and how things can work.
I saw a video where they showed them using a while loop to make a password system, where they set up a break in case the password is correct, it will break, then print. You put in the correct password. But if you put in a wrong password, it will keep on printing incorrect, until you get it right.
Yes, you can do something like that. Now for us with our power, we're working on an, how do we tell people? You could use that, and you could do that. Usually for something like that, I wouldn't say don't do that, because now with a loop, it's not good to do that because a loop is continuous. So now, Aaron, let's say that you have a password system there. Would you use a loop to read out every single password within the system and then print wrong if it doesn't catch the password? Yeah, like a loop that reads out every single password, and if it doesn't see the password that you put, and if it doesn't see the correct password, and if your password isn't correct, it will continuously print out password incorrect.
It's better to use an if statement.
It's better to use an if statement, which is actually what we're going to be doing next class. For a loop, I would not recommend doing that because with loops, they go on continuously. Remember how I typed in the while without any parameters and then it kept on printing hello world? Yeah, my computer froze and it became slow. If you don't have any parameters and then it continuously does this, remember one thing that's actually crazy with computers. When you're programming your computer, you can genuinely break your computer. Like if you write something that continuously does something or just something that just isn't nice with your computer, you could genuinely break your computer. How long has this video been going on for? Because what? I remember once when I was filming a video with my phone, it started overheating.
I gotta go.
Alright then.
Tomorrow, guys, we have class if statement. I will share the notes with you. Yeah. I wasn't sure the venue later.
Yeah. So anyways, that's basically how loops go. Loops are used for processing data. I would not recommend it for password systems, especially when, let's say, you have a password system where you have 1 million users on your social media platform. Because now, then it would go through every single password. And like computers still have speed. They still have to check every single thing with addresses and stuff like that. It's just too much work. So anyways, let's continue PowerPoint presentation. Iteration based on real conditions. Use a while loop when you don't know how many times a task needs to be repeated, but you know when it needs to stop. The loop checks a condition true or false before every single lap. While loops are prone to infinite loops if the stopping condition is never met, always ensure the variables inside the loop change in a way that eventually triggers an exit. So you could say, keep sampling the sensor until it hits the stop button or increase the gain until the signal reaches the 1 volt. So now loop control statements, finesse and emergency, the break command. This is your emergency stop. It immediately terminates the loop and moves to the next section of the program, essential for preventing system overload. So as you said, it's very good that you check break statements. Let's say your loop is going on too much. We also have case statements, which is a different type of loop. There's a case statement, which is a different type, or which is basically like an if statement mixed with a loop, but I'll teach that in an even later class. We continue. This is the skip button. It tells the loop to ignore the rest of the code for the current iteration and jump immediately to the next one. Nested loop. A loop inside a loop useful for 2D data like pixels, where the outer loop handles rows and inner loop handles columns. So let's say you have something that you're processing. Let's say you're processing memory from a video game or something like that. Best practices and optimization. Pre-allocation, always create your empty arrays before the loop starts. If the computer has to resize an array during every lap of the loop, it slows down significantly. Always make sure that you use the proper loop array sizes so that your loop doesn't need to resize any of your arrays or add some stuff, because a loop can add variables to an array. Of course, it won't change what you have in your code, but when it's printed, it will seem as if it will show that it's changed. Don't calculate constants inside a loop if a value doesn't change during iteration. Calculate it once. Do not calculate inside of a loop. Do not use divisions or whatever. Make sure that all of that is done outside. When to avoid loops. In modern languages like MATLAB or Python, many loops can be represented as